So before defining inverse trig functions, let me briefly recall function itself and one-to-one function and the definition of inverse function. A function from a set x to another set y assigns precisely one element to each element in the domain. So let me draw a picture. Say we have set x, set y. A function f assigns exactly one value to each element in the domain. So we have, say, x1, y1, x2, y2, and so on. Sometimes your function assigns same value to distinct elements x1, x2 in the domain. This is still function, but we want to say this is some nice function. Well, so definition. Here is a quick definition. A function is said to be 1 to 1 if it is, this function is said to be 1 to 1 if it maps distinct elements to distinct elements in the domain. So this is 1 to 1. What about this? This is not 1 to 1. Well, our purpose is to define inverse function eventually. Imagine you want to you define inverse function for this function f. Well, you want to go backward, then you are assigning two values to single value in the domain of inverse. That's not possible. The definition of function asks only one element to each element in the domain when you define the inverse. So if your function is not 1 to 1, no way to define inverse. If your function is nice, if your function is 1 to 1, no obstacle for you to define the inverse. So definition. Okay, suppose you have function f, and you want to define inverse. Let me use color. Inverse f, like this. Here, small x is mapped to small y, and inverse will do exactly the reverse of this guy. So f maps x to y, then f inverse will map small y to small x. So that's it. That's the definition of inverse. So inverse is defined by suppose you have this situation. Your original function maps x to y, then your f inverse maps small y to small x. So f inverse does exactly the inverse of the reverse of original function f. So when you're given graph, you can tell whether the function is a 1 to 1 or not. So for example, you can use horizontal line test. So the idea is you draw a horizontal line and you check intersection of this horizontal line and your graph. Once this horizontal line intersects your graph more than once, your function is not 1 to 1. For example, sine curve, cosine curve, tangent curves are not 1 to 1 because, for example, sine curve repeats the same pattern forever for every 2 pi. So once you draw a horizontal line, you will see infinitely many intersections. That's why the function is not 1 to 1. But there is way to define inverse somehow by restricting the domain. So that's what we will discuss in the next slide. Okay, so first thing is inverse trig function. Well, sine graph repeats the same pattern for every 2 pi, so it's not 1 to 1. So the function is not 1 to 1. However, we restrict the domain so that our curve intersects horizontal lines at most once. So we restrict the domain from negative pi over 2 to pi over 2. So then, as you see, this is a portion of sine curve on this restricted domain. And as you see, this passes the horizontal line test. So we have one-to-one function. So we restrict our domain to from negative pi over 2 to pi over 2. So here is a quick diagram. What sine curve does is to assign some value to angle. This is what sine curve does. So the domain of sine curve in this case is restricted interval, and then the value can be anyone between negative 1 and 1. So we are restricting our domain onto this interval so that sine curve assigns some certain value to any angle. So inverse of sine, what inverse of sine does is to assign angle to certain value. So that's exactly what it does. Okay, here is a quick example. So we want to find inverse of sine inverse applied to 1/2. Well, so this 1/2 is some certain value here, and the result must be some angle. So we are after some angle so that 1/2 is the assigned value. So we can start with letting sine inverse of 1/2 equals x. Well, this is unknown, so we can use unknown x. So 1/2 is somewhere here, and we are after some angle x. This is exactly what inverse of sine does. What if you apply sine? Then what we can say is sine of x must be 1/2. So you are after angle so that sine value is 1/2. So where is 1/2? Can you tell me this angle? Yes, pi over 6. That's it. So x is pi over 6.